Hello everyone, this is numerical number 5 which is mainly based upon capacitor. So let us begin our solution. So here is the question. Two parallel plate air capacitor of same capacitance C are connected in series to a battery of EMF E. Then first capacitor is completely filled with a material of dielectric constant K. What will be the change in effective capacitance of the series combination? So the question is, we have two parallel plate capacitors. Air capacitor means the medium between the plates is air. Of same capacitance, the capacitance of two capacitor, both capacitors is same, that is C, and are connected in series to a battery. So these two capacitors are connected in series to a battery of EMF E. This is the first condition. Then first capacitor is completely filled with a material of dielectric constant K. So after which second condition is that now the first capacitor is being filled with a material of constant K. So the question is, what will be the change in effective capacitance of the series combination? So you have to find the change in effective capacitance of the series combination, that was in initially when there was air as a medium between the two capacitors, and second condition when there was a dielectric medium of capacitance uh, of first, when there was a dielectric medium of constant K, dielectric constant K between the plates of first capacitor. So let us begin our solution. So here is the graph. As you can see, let C1 is equal to first capacitor and C2 is your second capacitor. Here this is your battery. So both capacitors are connected with battery. It is given that EMF of battery is E. C is equal to capacitance of air capacitors. Both capacitors C1 and C2 have capacitance C as it is given in question. So C1 is equal to C2 is equal to C, and K is dielectric constant of material inserted in capacitor C1. It is here given in question. Capacitor C is completely filled with a material of dielectric constant K. This is the second condition. So K is the dielectric constant of material inserted in capacitor C1, and this is change in effective capacitance of combination is equal to delta C is equal to question mark. So we have to find this, what will be the change in effective capacitance, or you can say net capacitance of the combination. So initially when no material is inserted in capacitors, then so first we will calculate what is the net capacitance of this combination when there was only air between these two capacitors, plates of these two capacitors. So let us first measure what is the net capacitance of this combination when there is no dielectric medium. So since these capacitors are connected in series, as you know the formula of series is 1 upon C net. So C series initial means first condition when there is no dielectric medium. So 1 upon C series initial is equal to 1 by C1 plus 1 by C2 is equal to 1 by, as C1 is C, both capacitors have the same capacitance value. So in place of C1 we have to keep C, and in place of C2 we have to also keep C. So it becomes 1 by C plus 1 by C is equal to 2 by C. So 1 by C series initial is equal to 2 by C. Thus C series initial will be equal to C by 2. So this is the net capacitance when there was no dielectric medium. So this is our net capacitance of the combination or this whole system when there was no dielectric medium. So let us now find what is the final capacitance when there is a dielectric medium. So finally, when material of dielectric constant K is inserted in the capacitor C1, then as you know that if a material of dielectric constant K is inserted in a capacitor, then its capacitance increases the K times, that is the dielectric constant time of the capacitor. So initially its capacitance was C, and we have inserted a dielectric medium of dielectric constant K, so its capacitance, new capacitance becomes K into C1. So this is the new capacitance of first capacitor, while second capacitor is same because there is no dielectric medium inserted in that. So here C1 is will be equal to K C1. So new capacitance of C1 is changed. So now this is Kc. So again the net, we will calculate what is the net capacitance of these combination in this situation. So 1 by C series final means finally when we have dielectric constant in this capacitor, so 1 by C series final is equal to same formula, 1 by in place of C1 we have to place Kc1, so 1 by Kc1 plus 1 by C2. So this is equal to 1 by Kc plus 1 by C is equal to 1 by C inside bracket 1 by K plus 1. If you will take 1 by C from common, from these two you can take 1 by C common. 1 by C, here is also 1 by C, here is also 1 by C. So if you take 1 by C common, here you will get 1, this is your 1, and here you will get 1 by K, this is your 1 by K. So 1 by C inside bracket 1 by K plus 1. If you will solve this, you will get 1 by C inside bracket 1 plus K by K. So your 1 by C series final is 1 by C 1 plus K by K. So thus C series final is equal to Kc or Ck by 1 plus K. So this is the final capacitance of this whole system. This is the new capacitance of the combination. So we get initial, now we get final, now we will find change. So final, when material of dielectric constant K is inserted in capacitor K, therefore change in effective capacitance of combination will be K delta C is equal to C series final minus C series initial. As you know that we have calculated C series final was Ck by 1 plus K and C series initial was your C by 2. So change in effective capacitance of combination delta C is equal to C series final minus C series initial. C series final is this value is C series final Ck by 1 plus K, and minus, here we have minus, after that C series initial. So this value is your C series initial. So you get Ck by 1 plus K minus C by K. If you solve this, you will get K minus 1 divided by K plus 1 whole multiplied by C by 2. So delta C, your delta C is finally K minus 1 by K plus 1 whole into C by 2. So this is your delta C. So delta C is equal to K minus 1 by K plus 1 whole multiplied by C by 2. This is the answer of your question. Thank you and have a nice day. If you have any problem confusing regarding any topic, please tell me in comment box. I will try to help you in my next video. Thank you and have a nice day.